Hello friends. So in the last video we have seen how to check the continuity of the given problems. Okay, but in that I told you that means I think I have solved two examples. One is simple function and another one is which is given in the form of less than and greater than. Okay, so their simple function is given with one continuity point, as well as we have checked the continuity of that greater than and less than function with continuity point. Means in the both examples continuity point was given. Okay, now I am going to teach you some 2-3 questions. Okay, same thing, normal function and that other function. Okay, we have to check the continuity, but the continuity point is not mentioned. Okay, now continuity point means what? That x is equals to value is not mentioned. Okay, so let us have the one example. Okay, that is f of x is equals to x cube plus x square minus 1. Okay, so here you have to check the continuity of this function, but here continuity point is not given. Then how to simplify? See, whenever the continuity point is not mentioned, okay, that time you have to assume the continuity point from the set of real numbers, okay. So here, before choosing that continuity point, one sentence you have to write it for such type of example. That is what? Clearly function is defined at all, okay, at all points of the real line. Okay, see now this sentence is fixed for such type of example wherever the continuity point is not mentioned. Okay, so here, so I have written clear this function is defined at all the points of the real line. Okay, so this is continuous at every point of the real line. Okay, so let us consider one continuity point from the set of real numbers. So I will take let C belongs to R be any real number. Let C belongs to R be any real number. So we have taken C as the real number here. Okay, so therefore now f of x, okay, is what here? X cube plus x square minus 1. Okay, now you have to check f of c, because see, this is a simple function. Simple function definition is what? That is limit x tends to c, f of x is equals to f of c. So here I am calculating f of c, and here c is c only. Okay, so substitute x is replaced with c in the function, that is c cube plus c square minus 1. This is your f of c value, and limit x tends to c, f of x is equals to limit x tends to c, because having c only, so I am taking c here. Now f of x is what? That is x cube plus x square minus 1, or which is equals to, now put the limit as x tends to c in the function, that is c cube plus c square minus 1. Okay, so here if you observe f of c value and the limit value, see here c cube plus c square minus 1, c cube plus c square minus 1, both are equal. So therefore limit x tends to c, f of x is equals to f of c. So that f of c and limit value is equal. So therefore what? This given function is continuous. So here to conclude, therefore f is continuous function. Okay, I hope that you understood this. Okay, so I have taken this without continuity point with a simple function. Okay, now I'm going to solve the same type of example, but with not with a simple function. I will choose the function which is defined in the form of less than and greater than. Okay, so let us have that type of example. F of x is equals to x plus 2 if x is less than or equal to 1, and f of x is x minus 2 if x is greater than 1. Okay, so this is the function. See here again they are not given at x is equals to, means what, that continuity point is not given for this function also. Okay, so as I said, what I have written the one sentence for the previous example, that sentence is fixed whenever the example without continuity point. Okay, so therefore you write that sentence clearly: function is defined at all points of the real line, Okay, now here whenever we have the function of this type, that is less than and greater than, and the continuity point is not mentioned, and that example can be simplified in 3 steps. Okay, here limit point is what? 1. So therefore your 3 cases are what? First case is c is greater than 1, second case c is less than 1, and third case c is equals to 1. Okay, so we have to check the continuity of this function in these 3 steps. So take the first case. If c is greater than 1, and keep in mind, for the first two conditions, this c is greater than 1, c is less than 1, you have to use the first definition of the continuity, that is what? Limit x tends to c, f of x is equals to f of c. That first definition you have to use it. Okay, so first I will find f of c is equals to, okay, what is, now for c is greater than 1, see here, where is greater than 1 is here. So for greater than 1 function is what? X minus 2, but in the place of x what we are having? C. So in the function whenever x is there we have to substitute c, so therefore answer is c minus 2. Okay, and you have to take limit x tends to c f of x, which is equals to limit x tends to c, f of x is what? Again same. See, we are checking the continuity for which condition? Greater than 1. So for greater than 1 function is x minus 2, so which is equals to, now substitute the limit as x tends to c, so again it becomes c minus 2. So again both answers are same, so therefore limit x tends to c f of x is equals to f of c. Okay, so therefore f is continuous at all real number greater than 1. Okay, so this function is continuous at all the real number greater than 1. Okay, this is first case. I will do the second case also. If c is less than 1, so first you have to calculate f of c. Now for less than 1, your function is what? X plus 2, but in the place of x I am having c, so your function will become what? C plus 2. And you have to check the limit now. Limit x tends to c, f of x is equals to limit x tends to c, where f of x is what? X plus 2, so which is equals to, now put the limit as x tends to c, so it becomes what? C plus 2. If you observe f of c value and limit value both are same, so therefore limit x tends to c f of x is equals to f of c, both are equal, so therefore f is continuous at all real number less than 1, and all real number less than 1. Okay, so here we have checked the first two conditions. Okay, and one more thing I will tell you here, always for such type of example you will have the function is continuous in first two conditions. The third condition will decide whether the function is continuous or discontinuous. Okay, so I will rub this and I will take the third condition. Okay, so let us check whether this given function is continuous or discontinuous. Okay, that is depends on the third condition. Okay, so I will take the third condition. The third condition is what? At c is equals to 1. C is equals to 1. So first I will take f of c, or which is equals to f of 1. Okay, and f of 1 meaning is what? Equals to 1. Where is equal sign? Here. Equals to 1. Function is what? X plus 2. But here x place is taken by 1. So in the place of x we have to put 1. So it is 1 plus 2. Answer is 3. Okay. So whenever you are taking checking the third condition, for this third condition always you have to take the second definition of continuity, that is LHL, RHL. So let us find LHL. Definition is limit x tends to c minus f of x, which is equals to limit x tends to, now c is what? 1. So 1 minus LHL means what? Less than. For less than 1 function is x plus 2, which is equals to, now put the limit is x tends to 1, substitute 1 here, so 1 plus 2, answer is 3. Okay, now find RHL. Definition is limit x tends to c plus f of x, which is equals to limit x tends to c, sorry not c, 1 plus, now RHL means what? Greater than, and for greater than function is x minus 2. Now substitute the value as x tends to 1 here, so it is 1 minus 2, answer is minus 1. So 1 minus 2 is what? Minus 1. If you observe LHL and RHL, okay, LHL is 3 but RHL is minus 1, which is not equal, therefore what? F is discontinuous. F is discontinuous, or you can conclude F is not continuous. Okay, so this is the example where the continuity point is not given. We can solve in this 3 steps. Okay, so let us have some more examples on this continuity part. Okay, so whatever I have solved with last video and this video, okay, the same type of examples you will find in the exercise. Okay, so go through this first 2 videos carefully, so you will not find any difficulties in the exercise. Okay, so this is the exercise 5.1. see, in this exercise I am not going to solve all the questions. Okay, I will solve some selected questions, okay, which are the same type that we have to solve it as a homework part. Okay, so have the first example. Prove that the function f of x is equals to 5x minus 3 is continuous at x is equals to 0, comma, at x is equals to minus 3 and at x is equals to 5. At x is equals to 5. So you have to check or they have said prove that this function is continuous at these 3 points. Okay, so in this I will show you one or 2, then remaining you do it. I will show you for any one point at x is equals to 0, at x is equals to minus 3 and at x is equals to 5. Okay, for all the points you have to show that this function is continuous. I think I will prove it for x is equals to minus 3 at x is equals to minus 3. You do it as a homework part for x is equals to 0 and x is equals to 5. If you see the function is normal. So therefore which definition? First definition. So first we will check f of c. But c is what? Minus 3. So f of minus 3 is equals to. It means what? In the function wherever x is there, we have to put what? Minus 3. So 5 into minus 3 and this minus 3 as it is, or which is equals to 5 into minus 3 is minus 15 and this minus 3 as it is. Minus 15 minus 3, answer is minus 18. Okay, and you have to check the limit now. Limit x tends to c, f of x which is equals to limit x tends to minus 3. Now f of x is what? 5x minus 3. So which is equals to, now here limit is x tends to minus 3. So in the place of x, you have to substitute the value is minus 3. So 5 into minus 3 and this minus 3. So 5 into minus 3 is minus 15 and this minus 3. So answer is minus 18. So therefore f of c value and limit value both are same. So therefore limit x tends to minus 3, f of x is equals to f of minus 3. So therefore what? F is continuous at x is equals to minus 3. At x is equals to minus 3. Okay, you check it for at x is equals to 0 and x is equals to 5. Okay, I will rub this. I am going to take next question. Okay, so the next question is f of x is equals to 2x square minus 3 at x is equals to 3. This is the second example. Okay, here now they have said examine the continuity, means what to do? Check the continuity here. In the first example they have said prove that it is continuous. Obviously that will be continuous only then. Now here you have to examine, means what to do? Check the continuity. So let us find. See, this is a simple function. So therefore you have to use the first definition. F of c is equals to, but c is what here? 3. So f of 3 is equals to, in the function wherever x is there, we have to put 3. So 2 into 3 square minus 3, or which is equals to 2 into 3 square is 9 minus 3. Now 9 into 2, 18 minus 3. So answer is 15. Answer is 15. Okay, and limit x tends to c, f of x which is equals to limit x tends to 3, because c is 3 here, and f of x is 2x square minus 3. Now put the limit as x tends to 3 here. So 2 into 3 square minus 3. So 2 into 3 square is 9 minus 3. So 9 into 18 and minus 3. So answer is 15 again. So if you observe f of c and limit, both are having same. So therefore limit x tends to c, f of x is equals to f of 3. So therefore f is continuous. F is continuous. Okay. So further examples, okay, I will solve in the next video. Okay, so I think you all of you are having the notes I have sent of the same topic. Please go through the notes, practice the examples. Thank you.